Hello and welcome, Mr. Zlevich here, and here comes the screencast on similarity. We're going to try to prove figures can be proven similar, or try to show that figures can be proven similar through a series of geometric transformations. And the biggest difference, and you'll see here in just a few minutes, is that to prove images are similar, we include that fourth transformation of dilation. So let's go to our Edmodo site and log in and get right into it. Our group is transformations number 5, and we're going to open up our folder on similarity. And you can see our screencast is listed right there. That's what we're taking part in right now. When we talk about similarity, similar figures have the same shape and angle measures while corresponding sides are proportional. And that's the key difference, is that we use the dilation or scale factor when proving similarity, because similar figures do not have the same size while the angle measures are the same. Similar figures are either enlarged or shrunk by a scale factor. In the past, we've used ratios or angle formula or side formulas to show similarity, but this recent trend in transformational geometry, I think, is a good trend in that once you've mastered the transformations, you can really use those skills to show other geometric notions and always come back to the transformations. So similar figures, they can be proven similar through a geometric translation or a series or combination of them, including a dilation, and the dilation being the key factor there, because similar figures are either dilated by a scale factor of greater than 1 to enhance or enlarge them, or by a scale factor of less than 1 to shrink them. Our first resource here are our notes from Math is Fun, and if that opens up for us, we will get right into it. Is it opening up for us? Let's try to open it up in a separate one. There we go. Similar shapes. Two shapes are similar when the only difference is size and possibly the need to move, translate, turn, rotate, or flip, reflect one around. And in the example picture here, the blue triangle and the red triangle are said to be similar because all the angles have the same measure. And they certainly look like the same figure, and the difference here would be the red triangle would be a shrunken version of the blue triangle, or the blue triangle could be an enlarged version of the red triangle. Resizing is the key. If one shape can become another using resizing, specifically a dilation, then the shapes are similar. It can be hard to see if two shapes are similar because you may need to do turns, flips, and slidings as well, as you will see in the upcoming gizmo. A couple examples of similar shapes. You have one that's been just resized, our triangle example from above. You have these dewdrops, so to speak, that have been resized and reflected. And then our pentagons here, the red pentagon and the gold pentagon, there's been some resizing, and it looks like about a 45-degree clockwise rotation of the from red to gold. Why is it useful to understand similar figures? Well, you really have to distinguish between similar and congruent figures and understand the properties that are kind of involved in both. When two shapes are similar, then the corresponding angles are equal, which is the same as congruent figures, but the lines are in proportion. And while congruent figures, lines are in proportion, a 1-to-1 ratio, similar figures extend beyond that 1-to-1 ratio. I ask my students all the time, are congruent shapes similar? Well, yeah, I guess they are, because if you took a congruent shape and multiply it by a scale factor of 1, you would have the same shape, and they would be said to be similar. The Math is Fun always wraps up with a nice, in this case, a nice comprehensive 12-question quiz that can test your knowledge of similarity and review some of the ideas of congruence. Our next resource is the Khan Academy website, and we'll load that up. It takes us right to our similarity and transformations page, and in this section There's just the one video, but it's a critical video to understand the steps involved in transforming the figure. And it's trial and error. I mean, the gizmo, you'll get better as the gizmo as you go on and practice. But we'll start this thing by asking ourselves which points correspond with which points, and trying to go through a series of transformations to see if we can, in fact, show that they're similar. And then finally, the gizmo, which is listed right below the quiz. And we're back here at the gizmo for exploring angle preserving transformations and similarity. A little technical gaffe there. But they're asking us here if we can show that triangle ABC and triangle DEF are in fact similar. We look at our corresponding angles here. A corresponds to D, B to C, and C to F. So I will start by trying to line up A and D immediately. And I was able to do that. And we will dilate our triangle. And I think we've clearly shown that since we cannot map ABC onto DEF, that the triangles are in fact not similar. And we are correct. We'll take a look at the next one. It looks like it's a rectangle. Our rectangles A, B, C, D, and E, F, G, H similar? Yes or no? And we're going to try to perform a sequence of angle preserving transformation that maps the two. Angle A maps onto or corresponds to E. So let's see what we can do. That's always a good place to start. Okay, so we're moving A to E. Alright, and it looks like that rectangle is in a different orientation. So we're going to have to rotate this thing as well. Let's rotate about our point there. And I think we're in good shape now. And this thing needs to be shrunken down to see if we can map it onto the purple triangle. So we'll stay with our point of reference E there and see what happens if we can shrink that thing down. Now looky there. It looks like we mapped it right on there. And we can take a look here and look what we did. We translated it by 1/2 unit to the left and up 5 units. We rotated it 90 degrees around the common point E here, and we dilated it by a scale factor of 1/2 to map it onto there. I also wanted to show you on here, they give you a series of hints that you could use, and they probably take you through a similar series of steps. Looks like they used point H as their point of reference in the picture, but there's many ways to prove that these things are similar. So we're going to say yes and click on check answer. And once you pass this quiz, get 5 correct in a row. If you are logged in, they will give you an award and move you on. If you are not logged in, they will tell you good job, and you can move back to our Edmodo folder. Completing the objectives, make sure that you do in fact watch the micro lectures, and when it's all said and done, you pass that quiz, and you are done with screencast number 8 on similarity.